Okay, good morning students. So now we are going with the next chapter, that is called ellipse. So ellipse, usually it is divided into two parts. Ellipse is divided into two parts. One is known as a horizontal ellipse and another one is called the vertical ellipse. So I will be doing only the horizontal ellipse. Please listen this ellipse carefully, the concept of ellipse. I will be doing only horizontal. In case of vertical, please do it yourself. When you complete with the vertical ellipse, make sure you send click the picture and send in my own messenger, all the students. So here, listen this horizontal ellipse careful, because ellipse and hyperbola is almost same. There's only a little bit difference with the eccentricity only. So almost it is same. So listen carefully with this horizontal ellipse. This is the horizontal ellipse. Here, this becomes the center of the ellipse. And now from this point to this point, let me take this one as a capital A and take this one as a A dash. So from this center to till this point, the distance taken here is nothing but distance is A. Distance is A. Let me write here, distance is A. So therefore this A is called the vertex point. Here vertex point will be A, 0. Now since we have two vertex in case of ellipse, we call that one as a vertices. So another point will be here, which is, let me take this one as a V dash. V dash is negative A, 0. So therefore, first point we are going to write is coordinate of vertices. We are not vertex but vertices, but in parabola we have only one vertex, so therefore we call vertex, but this case we have two vertex, we call this one as a vertices. V dash will be plus or minus A, 0. The next point what we are going to write here, it is equivalent to, see, this point we call this one as a focus, but in case of ellipse we have two focus, so that is why we call that one as a fossa. So please remember, from this center to vertex, center to focus, the distance is given by AE. Distance is given by AE. So therefore focus point here will be AE, 0. Similarly, this side, let me take S dash, which is negative AE, 0. Please, the important concept is from center to this vertex the distance is A units, and from center to till this focus the distance is AE, where E stands for the eccentricity of the ellipse. So therefore, coordinates of foci, we call this one as a now foci, not focus, is we have S dash is plus or minus AE, 0. Next one we will see is length of major axis. Length of major axis. Here, this is called the length of major axis, and from this point to this point, let me take this one as a B dash. This is called the minor axis, length of minor axis. From center to till this say is a length of semi-major axis. A to A dash becomes the length of major axis, but center to till here A becomes the length of semi-major axis. So length of major axis, which is along x-axis, is equivalent to 2A units. Definitely, we have from this point to this point A, definitely this point to this point becomes A, so total length it becomes is 2A units. So length of major axis, which is along x-axis. For horizontal ellipse, major axis is along x-axis and minor axis is along y-axis. For vertical I will tell you later. Now similarly, length of, under this length of minor axis. length of minor axis, which is along minor axis is along y-axis. We have along y-axis is equivalent to 2b units, because from here to here the distance taken is b, from here to here the distance taken is a. B plus b becomes the 2b. We have 2b units. Number 4, equation of major axis. Equation of, use the concept that we have learned under parabola. Equation of major axis. Right now major axis is along y-axis. It does not lie on the major axis is along x-axis. It does not lie on the y-axis. So when you write equation of major axis, you are going to write y is equal to 0. That means major axis does not lie on the y-axis. If it does not lie on the y-axis, obviously it will lie on the x-axis. Similarly, equation of minor axis. When it comes to equation of minor axis, where is the minor axis? Minor axis is along the y-axis. It does not lie on the x-axis. So therefore, x is equivalent to 0. Number 5, we are going to see equation of directrices. Because here we have two directrices. One directrix we have seen under parabola. Here we have two directrices. That is, one directrix is somewhere here, say D1, D1 dash, and another directrix will be here because we have two focus points. Here it is D2, D2 dash. Now, like from this center to till this directrix, the distance is given by A by E. Distance from center to directrix is given by A by E. Center to vertex distance is A, center to focus distance is AE, and center to directrix the distance is A by E. Now since it is intersecting x-axis, we have x is equal to A by E this side, and then here x is equal to negative A by E. So therefore, equation of directrix is x is equal to plus or minus A by E. Simple as that one. Number 6, we have length of Latus Rectum. Length of Latus Rectum is given by 2b square by A. Please get thorough with 2b square by A units. This is the length of the Latus Rectum. Okay, so now last point we will see, here it is, number 7, coordinates of lateral recta. Now let's see, in this case, coordinates of lateral recta. See, this is a latus rectum. A line passing through the focus is called latus rectum. Say this one is L1, this becomes L1 dash. This L1, what's the coordinate? You know, from here to here, the point, the distance is AE. What about the distance from here? This distance becomes B square by A. Because L1 to L1 dash is the length of latus rectum, which is 2B square by A. Half of this becomes B square by A. So this point will be AE, this is the X value, and what's the Y value? B square by A. Similarly, L1 dash, what's here X coordinates? It is AE. But what about Y quadrant? It is in negative quadrant. So this becomes negative B square by A. Similarly, this side, another latus rectum is there. Say this is L2. This one is L2 dash. What's the L2? From here to here, what's the distance? Point, now coordinate point is negative AE. What about this one? This becomes B square by A. What about this point now? Coordinate point is negative AE. This point is negative B square by A. Or otherwise, when you write coordinates of lateral recta, you will write plus or minus AE, comma, plus or minus b square by a, plus or minus a comma plus or minus b square by a. Then no need now. Now you don't need this, okay? Because the focus lies on the x-axis. You can write this one as the points are, take one positive value, b square by a, or one positive value and another negative value, negative b square by a, and one negative value and another positive value. Last one it is one negative value and negative b square by a. So now the last one, what we will see here is, we will see the equation of this ellipse. We have seen the major axis is along the x-axis. So equation of this ellipse is given by x square by a square plus y square by b square is equivalent to 1. Major axis is along x-axis. Yes or no? Major axis is along x-axis. This is the major axis. So A will be below x. Minor axis is along y-axis. It will be below y. Then the number 8 point, we have eccentricity. Eccentricity in this case will be always less than 1. And it's given by E is equal to root of 1 minus b square by a square, or you keep this formula, b square is a square of 1 minus e square. Now ellipse, you need the eccentricity value less than 1. In order to have eccentricity value less than 1, you need to subtract. But in case of hyperbola, eccentricity value should be greater than 1. In order to have greater than 1, here it becomes plus. It is easy to remember. Then here eccentricity value less than 1 means definitely modulus of SP divided by modulus of MP is less than 1. In case of ellipse. In case of parabola, modulo SP divided by modulus of MP was equal to 1. But this case is less than 1, which implies modulus of SP is less than modulus of MP. Definitely a small number divided by a greater number will definitely give less than 1. So which means if this is a horizontal ellipse from S to P and P to M, S to P and P to M, this distance will be always less than MP. If this is 2 units, MP becomes 3 units. Then only 2 divided by 3, the value will come less than 1. That is why in case of eccentricity, here the eccentricity value is always, in case of ellipse, eccentricity value is always less than 1. So I want you to do the vertical ellipse. Now, in case of vertical ellipse, this A will be on the y-axis. This is a vertical ellipse. If this is a vertical ellipse, this is a vertical ellipse. Vertex will be on the y-axis. This will be 0, plus or minus a. When it comes to focus, focus also will lie on the y-axis. In case of horizontal ellipse, vertex, focus, directrix is always on the x-axis. But in case of vertical ellipse, this a will be on the y-axis. This will be 0, plus or minus a. Length of a major axis. Length of a major axis will be along y-axis, but it will be 2a units only. Length of minor axis in case of vertical ellipse, it will be along, not y-axis, along x-axis. Please do it. Equation of major axis, it's on the y-axis. It does not lie on the axis. The axis is equal to 0. Just check opposite. Equation of minor axis will be y equal to 0 because minor axis is along now x-axis. It does not lie on the y-axis. Equation of directrix will not be x here. It will be y. Y equal to plus or minus a by e. Length of latus rectum will remain same. When it comes to coordinates of lateral vector, you will just change the position because a now lies on the y-axis. Plus or minus b squared by a, comma plus or minus a by e. Similar. Eccentricity will remain same. Please do vertical ellipse. Try yourself. If you have any doubt, please ask. Thank you.